Hi, this is Ishan Sinha, and I'm going to be covering the material selection section. So on to slide 28, where I talk about the materials pre-selected for use in the landing gear. So some common aerospace materials were selected based on density, yield strength, and stiffness properties. So the material selected has to be able to support the maximum loads experienced by the landing gear and must be in a prescribed stiffness range. So the material has to be stiff enough as to support the landing loads experienced uh, through service, but can't be too stiff as to transfer all these loads to the aircraft frame. And you can see this in the picture on this slide. So on to the next slide. These are the materials that were pre-selected based on the criteria I mentioned before. So out of these materials, the 300M steel is the heaviest, but is also the strongest. The CFRP is the lightest, but also costs the most. Some other materials that have great properties are aluminum 7075T6 and titanium 6AL4V. So shape factor is really important to when considering the material selection. So shaped sections are able to carry loads more efficiently than completely solid sections. So as a result, the solid section, solid square section, I-beam, and hollow tube were analyzed based on shaped factor formulas. And using approximate dimensions, the I-beam was determined to be the most efficient shape in bending. However, this was not chosen for the bottom and vertical strut due to the loads experienced on those sections. Those loads are those members are experiencing loads in every direction, and as a result have to have a more uniform shape. So the I-beam cross-section was chosen for the top strut, and the hollow tube cross-section was chosen for the bottom and vertical struts. So now onto the material index slide. So the function is that the landing gear material has to be able to support the landing loads of the R-44 aircraft. Now the objective of this material index is to reduce the weight. That's the main objective, and we're also going to consider cost in this material index. Some constraints are the yield strength and specified length, and some free variables are the stiffness range that I mentioned before, the cross-section, and of course the material. So as I mentioned before, we have to consider shape factor when choosing the material. So some equations, some shape factor formulas were rearranged and substituted into the material index as shown in this slide. So when substituted, this is the final material index that will be analyzed for the landing gear. So based on this material index criteria, the values were substituted into these equations, and as a result, in the first material index, when not accounting for cost, the CFRP performed the best by far. However, it did not perform well with regards to cost, as it's very expensive material. Some other materials that performed very well were the aluminum 7075T6 alloy and the titanium alloy. So now onto the final selection slide. So while the CFRP performed very well in the first material index, it has to be disregarded because of the cost of the material and the feasibility when integrated into the design. So it's really hard to bolt CFRP, and if you want to do so, you have to specially thread the member, which will likely increase the cost even more. So as a result, the aluminum 7075 T6, which performed slightly better than the titanium alloy, was chosen for the bottom and vertical struts. And because the load experience on the top struts were a little bit more, the titanium alloy was chosen for the top struts. So that is the material selection for the R-44 landing gear.